Hello everyone, welcome to the day 7. So in the yesterday's session, we have been just seen about a for loop, how the syntax of a for loop, how to just make a nested for loop, nested while loop, how to just avoid going into an infinite loop. We have been just seen a break, continue, and pass. Conditional statement. So all these things we have been just seen in an yesterday's session. So today we are going to see about a data type operations. So the first data type is a number. So let me take a pen here. So number is a data type which stores only a numeric values. So that is called as an data type number. You have been just seen this in previous sessions. So this is an in detail version of how to just operate with the data types. So if you are just storing any number of values, that is numeric values, then that data type is called as a number data type. So if you are trying to store any of other values other than a numbers, then its data type will be automatically changed. But whenever you are going to store the numerical values, then it is called as a numerical number data type. So we are having a types here. So in that the first type is int. So we are going to call it as an signed integers here. So this can store either positive, negative, whole numbers. Whole numbers means like this 3, 2, 4 without having the decimal points. The decimal points will be absent. So the positive, negative, whole numbers are going to be stored. So here we are having two versions in Python 3 and Python 2. So in Python 2, we were having int and long int. So we'll be knowing about a long int version. So long int means it is going to store a larger number as compared to an integer. That is, memory will be too much high compared to the integer one. So, but whereas in Python 3, this long int have been removed and they have been provided an unlimited memory for int itself. So in Python 2, they were having two things, that is int and long. But whereas in Python 3, this long have been removed and they have been just given an integer with an unlimited memory. So this is all about int. Let us see the second one, that is float. Float is same as an integer data type, but it is going to store the positive and negative numbers with decimal point, and the memory will also be more than the integer. The only difference for float is it is going to store the decimal values. So the next one is complex one. So the complex will be in the format of a plus jb. So a and b are a floating point numbers. So these two are floating point numbers. So j means root of -1. So this part, a part is real part, and this one is imaginary part. So this is a complex supporting which are being provided in Python. So usually in programming we won't think of a complex coding and all. It is complex number coding, which is in the format of A plus JB. So A is a real part, JB is a imaginary part. A and B is going to hold a data type of float, and J will be equal to -1. So these are all the three versions of a Python supports different numerical types. So the next one is number type conversion. So if the number x is in integer, you can convert that integer to an another type. Or else, let me just take a floating point. If we are using int of x and you are going to store that into an y, so 3.5 will be converted into a data type of int. After conversion, y value will be 3. So this is like number type conversion. In the same manner, now y will be in an integer. So if you need to convert this y into floating point, so you can pass a y. So initially it was 3.5, later it has been converted into 3. So now z will be converted into floating point, that is 3.0. So you can just make this into complex as well. So just you need to write a data type of what you are needed with. So this is a number type conversion what you are going to just see with. Okay, we can just see this in an pie chart. So this is a syntax. We can just see the execution over there. Okay, we can take a new file here, new scratch file. So we need a Python. We can rename it to day 7. So now I am just taking a x variable and just giving it as 3.5. So x is small one. Okay, fine. So I am taking y is equal to int of x. Now it is converting from float to int. So then z will be equal to float of y. Then m will be equal to complex of z. So you can just run this by just printing the values. Print y, print z, print m. That's it. So initially the x value was 3.5. So now it has been converted into integer. It is not going to store any after decimal point value. Hence 0.5 is removed. 3 is right. So later y have been converted into float, that is 3.0. So again that 3.0 is being converted into complex integer 3 plus 0j. So this is just a simple programs of number type conversions. Okay, let me take a pen here. So we are having some of our operations here. So the absolute operation, that is ABS. The syntax is absolute operation. It is an inbuilt function. So you can just write somewhere it is inbuilt function. There is no need to import any of a library for using this because it is inbuilt. As it is inbuilt, you need to use smaller brackets. What is the task of this one is, if you are giving a negative number, it will be just converted into a positive integer. So that is called as an ABS. So the next operation is like ceil operation. Ceil of this one. Here it is not an inbuilt function. It is a function which have been written in math. So if you need to use the ceil, you need to import math first. Import space math in your program and use this math.ceil. So what is the function of it? This one is like, if the number are being given in, if the number have been performed in any of a decimal point, irrespective of checking its number of decimal, it is going to round off to the next value. See, consider if it is 7.2 and 7.6. According to mathematics, if you are going to round it, it will be 7. But if you are using a ceil command, if you are getting any of a point digits, then it will be rounded to the next largest integer. So both the answer will be same. So if 7.1 also coming into picture means, it will be just ceiled to next integer, next highest integer. So this is called as an ceil operation. Okay, we can just see both of our operations here. So first I'm going to absolute of negative 45. ABS of negative 45. I am printing this, and again I am taking a value here for ceil. For operating a ceil, I need to import math. So math dot ceil 7.2. Okay, we can print it. Okay, it should become point here. 7.2, and you can see if any of a digit have been given, it will be rounded to the next value. 8.1 also, it should give 9, next positive number. Okay, the negative of absolute of negative value will be converted into positive here. Minus 45 will be converted into positive number. So you are importing the math. So as I told you earlier, ceil is not a function, inbuilt function. It has been written in math. So ceil 7.2, it has been rounded to the next largest number. 8.1, with only one decimal point also, it is rounding to the next value. So this is a another kind of a operation which have been just available in Python. If any of a decimal point comes, it is going to be switched to the next largest number. If this was a scenario, you can use this ceil. Okay, you can just go for an next operation. Okay, let me take a pen here. Okay, the next operation is exponential operation. So exponential operation is a method which is going to make you e raised to x. And this is also not an inbuilt function. It have been written in math. So you need to first import it. Later you need to write math dot exp, that is exponential. So whatever you are giving here, that will be converted into e raised to 2, and the answer will be given in this form. So this is called as an exponential function, and the next function is fabs. So this is also not an inbuilt command. So the fab operation and the ABS operation, that is absolute operation, are one and the same, but this is inbuilt. This is inbuilt, and this have been written in a math function. So we can just see these two operands working. So print math dot exponential value of e raised to x. It is e raised to 2. So next, so print dot fabs minus 45. So like this, you can just see the output here. So e raised to x and fab, it is going to make the positive number. So this operation is same than that of an absolute operation, but here you need to invoke the math. But here it is inbuilt function. ABS is an inbuilt. So e raised to 2 is 7.3. Okay, we can go for the next thing. Then and next value. So next we are having a floor. Okay, let us see our next function called as an floor operation. So seal is a one which is going to seal to the next integer if point 1 is given. If any of a point has been given, that will be sealed to next version, next largest number. But whereas in the floor, if you are going to give any of a point digit, it will be not sealed to the next largest number. Instead, it will be sealed back to the previous integer. If it is 7.6 also, it will be sealed back to 7. So whatever the decimal point coming into a picture, it will not round off to the next integer. It will be rounding off to the its least integer or a lesser one. So this is a floor operation. So the difference between floor and a seal is like, if any of a point is given, it will be round off to the next largest integer, but whereas in floor, it will be round off to the lesser integer. So later we can just see the natural logarithmic. So natural logarithmic means log to the base e. The syntax here is simply log. So there is another data type that is called as an log 10. So its syntax is log 10 and you are passing some values. So this is a two difference between natural logarithmic and log to the base 10. You can just see both of the things here. I guess you have been understood this floor concept. If you are getting point, it will be round off to the lesser integer. Okay, we can just see that, and again this floor is being present in a math function. Floor of 7.1. You can just see. So floor of math of floor of 7.6. So whatever the decimal point you are getting, that will be round off to the lesser integer, not a larger integer. So next we can just see the print of natural logarithmic, that is some values math of log of 100.12 print math dot log of 100.72. So this is natural logarithmic. So next we can go for log 10 logarithmic. So math dot log 10, the same values. So print log 10 math dot log 10 100.23. Okay, then let me just retain the same numbers. Print log 10 math dot log 10 100.72. So this is a logarithmic, natural logarithmic and base 10 logarithmic value. We can just see the difference here. So first we are going to see the floor here. Irrespective of greater than 0.5, it will be rounding to the lesser integer. If you are having these kinds of an application, you can go for floor. So in the same manner, you can see log natural logarithmic value and base 10 logarithmic value. The same values with the log e and log 10. It is going to make some difference. Okay, let me go for the next one. You are having, if you need to return a maximum in an array, so you can take some values here, but the values should be separated by comma. So this value can take a numbers here, 100, 200, 1000. So which is a maximum number that will be returned back if you are using this max method. There is a minimum method also. So minimum, like, which is a least value in this array. So again it can be separated by A, B, C, D. So this is minimum present in this array. So which number is minimum, that will be pushed to the results. So after minimum method, you are having mod-f method. So mod-f is the one which is going to give a fractional and integral part. So this is like fraction and integral part will be given if you are using this mod-f. So we can just see the method. These three methods in an PyCharm with its syntax. Okay, the first one is minimum value. Okay, it can be you can take maximum value. So maximum of 8, 100, 1000 is max of 1000, 100, 8, 1000. In the same fashion, you can see the other numbers. Maximum of 5, 6, 78. Max of 5, 6, 78. So this is maximum values. In the same manner, you can print the minimum of 8, 100, 1000 is. So okay, I've forgotten to write comma here. minimum of 8 comma 100 comma 1000. So print minimum of 5 comma 6 comma 7. So minimum value of 5 comma 6 comma 70. So after this we are having a mod of operation. So mod operation you are going to carry out. Okay, this is not an inbuilt function. Math.modf 100.12. So you will be getting the answers in fractions. Math.modf 100.72. So first we can see maximum is 1000 in between these three numbers. Between these three numbers, that is 5, 6 and 78, maximum is 78. In the same fashion, minimum is 8 in 8, 100 and 1000, minimum number. And the minimum number in 5, 6 and 70 is 5. So here fractional part and integer part will be given in a different values using mod f. So we can just see the next method here. Can take a pen. So the next operation is like power operations. So this is a one which is going to just make use of in a mathematics power 100 raised to 2 like this, or x raised to y. X and y can be given by the user defined value. So next comes a rounding operation. So here it is having two parts. First one is number, and you can give the option values like this. After how many decimal point you need to just round it off. If you are not giving this second one, it is an optional one. The default value is 0. So after the 0th decimal point, you are going to make a round off. If you are going to give it as 1, so if the number is like 76.563, so it is going to consider the second digit for rounding this first one. So the answer will be, you are going to just see how it is going to perform. In the same manner, after how many digital points, decimal points, this round off need to be carried out. So that is what this round off is going to be just provided. Okay, we can just see that. So print math dot power 100 comma 2. Both the values are different. So in order to make it separated, we are using comma. So you can just see the power operation in negative as well. 100 comma minus 2. So this is power operation. So let me just see the rounding operation. Round of 76.563. So default condition I am leaving it, that is 0. Print round of 76.563 by taking first decimal point. 76.563. By taking second decimal point, round it by using 76.563 at the third decimal point. So this is about round operation. It was another power. Okay, round and power I have been just typed here. See, by considering without having any conditions like decimal points, so it is more than 5, so 0.5, or it is equal to 0.5, hence it has been rounded to the next value. So by considering the first decimal point, that is after having merging you need to have a first decimal point rounding off. So by seeing the next one, it is being rounded to 76.6. So the second value, this value should be rounded off 56. So this, by considering the third one, it is going to be rounded off. It is not greater than 0.5, hence it is 56 itself. The third one here also the same. The next digit is not there, hence it is going to be left over like that itself. If the next digit is 6 here, so instead of 3, it will be rounded off to 75.564 like this. So next one is square root. So if you need to find a square root, you can just go for this method. So the next one is sine inverse of x and cos inverse of x. So the syntax here is square root of x. Here the syntax is a sine of x and b cos of x. So you can also see the tan also, b tan of x. So the answer will be tan inverse of this answer. So print math.sqrt square root of 100. So print math.sqrt square root of 7. Print math.sqrt square root of 49. So this is square root. So next you can just see the cos version. So print math.a cos inverse of 0.64. So inverse operation means it should be 0 and 1. So print math.a cos 0. So this is cos operation. In the same fashion, we are going to have a sine operation. So in the same fashion, we are going to see the tan operations as well. So we have been seeing about square root and sine inverse, cos inverse and tan inverse. We are just running it. So the first one, square root of 100 is 10, square root of 7 is 2 point value, and square root of 49 is 7. So this three values, two values are cos inverse, next sine inverse, next tan. So like this you can just perform any of a respective operations what you are going to do in a mathematics. So why we have been just covered all those things is this to make well versed with your Python operating systems. So it's syntax, how to operate it, how to write a different programs and all. I guess this one is informative. Let us see you all in the next videos. Thank you.